right, so good morning. Thank you everyone for joining us today to talk about iPOC, a new platform by Avadine. It's an Ignition native XBOC replacement built for scale. So who is this for is what we're talking about. So production and operations, automation, SCADA engineers, IT, OT, and cybersecurity, integrators, and enterprise SCADA teams. What we're going to talk about today is why teams are replacing XBOC, what iPOC is and what it is not, architecture, how data actually moves, deployment and support models, and after that we'll hop into a live demo and we'll go into a Q&A for anybody that wants to learn a little more. So I will go ahead and hop right in. So the problem with operating pump-off controllers at scale, common realities that we are hearing from our customers are there's slow feedback on remote commands, multiple tools for wells, plants, pipelines, so operators are having to fumble between different applications, vendor lock-in and upgrade friction. Engineers want real SCADA data, not delayed snapshots, and operators want confidence when they hit start and stop on these commands. So what we're hearing is companies are looking to move away from XBOC due to several reasons, some being high costs when you start adding the licenses and mobile and other add-ons, SQL polling architecture and command latency, difficult upgrades after customization, limited integration with broader SCADA systems, and separate UI from everything else operators use, just like I previously mentioned, multiple applications for looking at the same asset. iPOC is a modern Ignition replacement for XBOC. So real-time well status, run, stop, alarm, immediate remote control with confirmation, dynamometer cards, history, overlays, configurations and set points exposed remotely, and full audit trail and role-based security. What it is not is a feature for feature XBOC replace or clone is what we're saying. It's not a black box analytics product, and it's not a separate side system from SCADA. So it's meant to be a little more. How iPOC gets data is it uses native OPC tag reads, not SQL polling. So reads controllers like a PLC through Ignition. Same real-time tags engineers are already trusting and using today. No intermediate polling database, commands return feedback immediately. The results is no questions around if a command went through, if there's a delay, operators will see the truth in seconds, not minutes. And next, we'll talk about how you bring in a new well into iPOC. So this is very simple. You basically are going to select your OPC source, Ignition, kept server, top server, AutoSol, ACM. You select your controller type, enter an IP. iPOC automatically creates the tags, creates the database records, creates the device connections. So it makes it very simple, very easy to do. All of this happens in the background. No vendor call is required, so it makes it very simple to add new wells. So iPOC is built on Ignition. Ignition provides the real-time OPC connectivity, alarming and notification pipelines, historian and trending, security, auditing, and identity management, web and mobile UI right out of the box through Ignition perspective. So these are all the things we love about Ignition, already comes right in the box with iPOC. And iPOC leverages Ignition, it doesn't fight it. So we definitely are working hand in hand. And that kind of brings us to this next point around the deployment options themselves. So iPOC can be deployed in multiple ways. So there's a standalone version where you have a dedicated Ignition project, ideal for clean separation. And then we also have the embedded option, which is going to run inside your existing Ignition system, use project inheritance. Operators never leave their SCADA UI. They can navigate to that same well from their familiar app that they use today and go right into the iPOC screen for that well. Results are you have your wells, tanks, pipelines, plants on one platform, which makes it a lot simpler for operations and for reporting on all that data as well. So that was a real high level, just some key points about iPOC right off the back. There's a lot more to iPOC. And so I'm going to go ahead and hand it over to Pat Smith. And Pat Smith is going to share his screen and give us a walkthrough of iPOC, of what it looks like today. But for that, Pat, you want to do a quick intro?
Sure. Yeah. So my name is Pat Smith, and I've been in the industry for about 17 years now. PLC programming, SCADA, HMI programming. Uh, Before that, I was an operator in the oil and gas industry, and so I was able to learn the field. I was actually an operator on wells that had pump-off controllers and was a user of Xbox. So I'm very familiar with pump-off controllers and that product, but more so just understanding the pains that operations go through and why a solution like this is necessary. But fast forward a little bit, a little further in my career, I started doing a lot more with software development in the SCADA space, and that moved me into more of an lead architect type role, where I was helping facilitate how to integrate SCADA systems into the business, connecting it to business reporting solutions and data warehousing and things like that. And fast forward a little bit beyond that, I was doing a lot more architecture in terms of IT and doing chief architect role with integrating OT and IT systems together, and not just SCADA, but the entire infrastructure in regards to networking and systems on the IT side. So wide range of background, but a huge focus in oil and gas, a huge focus in well and facility automation. All right. So with that,
Thanks,
I'm going to
Pat.
jump straight into the demo. You betcha. Okay. So this is iPOC that I'm sharing here. iPOC, when it first launches, takes you straight to a home screen, which is a dashboard. The dashboard gives you a lot of flexibility on what KPIs you want to display. And there's a lot of flexibility that we have here. We've only created a few widgets to start, but this could be highly customizable for any of your operation, depending on what you want to do. So right now we have a default set of widgets that we put on the screen, but these can be removed, they can be moved, and we can add other widgets. And other widgets can be created very easily. So there's a lot that could be done here that we haven't even really tapped the potential of this dashboard capability. But we really like to highlight it and show off the ability to show high level data very easily, very quickly on this dashboard. This could be very powerful for control room or throwing up on a TV in the office and just monitoring how many wells are shut down, how many wells are running, how many wells have comm fails, how many wells have alarms. So this could be a very useful tool for operations to monitor the system as a whole and monitor system health. So one of the big questions I get with these numbers, though, is, okay, I've got, for example, and this is our demo environment, but for example, I've got 10 wells not communicating and I've got 5 wells shut down. Well, what 5 wells are those that are shut down? What 10 wells are those that aren't communicating? And that's always a challenge with dashboards and KPIs. How do I get to that data behind that metric? And typically you would have to navigate somewhere else to go find that information. Well, what we've done is taken advantage of Ignition's perspective capabilities in CSS, and we've made these flip cards where you can just spin these things around and show the information that's driving the data point. So these are the 5 wells that are shut down. And again, this is a demo environment, so a lot of this is dummy data, but it gives you an idea of what's possible with Ignition and out-of-the-box capabilities that you get with it. All right. One thing I'll point out while I'm here on the home screen is we do support local Ignition logins, just like every other Ignition system. We're piggybacking off of Ignition. We support Active Directory logins. We support all of the functionality that Ignition gives you out of the box, SAML, OpenID, multi-factor authentication through those services. We also have an alarm counter at the top here. So if there's any alarms active in the system, you always see them at a glance at the top of the application. This would be showing how many low priority alarms are in the system, how many medium priority alarms are in the system, and how many high priority alarms are in the system. And clicking this alarm counter takes you directly to those alarms. The other thing is we support theming. Again, ignition out of the box. So you can theme your application however you like. A lot of people like dark nowadays, so we have the ability to switch between different themes. We also support language. And so we can switch the application very quickly from English to Spanish. And now the entire application is in Spanish. The other thing is, as Al mentioned in the presentation, we support mobile. So I'll switch this to a mobile format really quickly just so you can see that. But if I switch this to, say, an iPhone size, all of the applications auto size to phone display. So you don't have to launch a separate application. You don't have to launch a native iOS or Android app. You can go straight to your Safari or Chrome or Firefox browser on your mobile device and navigate to the website, and it will automatically format the website to your mobile display. Okay, coming back to the application and desktop view, I'll touch on this very quickly and we'll get to kind of the main points we wanted to cover with the iPOC solution. Because we're running an Ignition, again, all of the things that you get with Ignition out of the box. That's why we built iPOC and Ignition. You get all of these things for free, essentially. We support alarming through their tag-based system. So all of our pump-off controllers that get created in iPOC have tags that are set to be alarms automatically per controller type. And if those alarms trigger, they show up in the application. They show up in the alarm status page, and they're logged in the historical alarm journal database. Okay, this is one of the windows that we've built for a lot of the solutions that we deploy for customers, but this is a very simple way to identify what alarms are triggering more often than others. So it's called a Pareto chart. And what this allows you to do is select a minimum priority, a start and end date, and then how many alarms you want to see. So show me the top 5 or 10 alarms in the system over this time range. And it's saying, hey, this demo playground tag has triggered 440 times in that time span. So you might want to go take a look at that alarm. So this is very helpful to identify what are my bad actors? What are my wells that are triggering alarms more than others? What are my wells that are shutting down more often than others? And go take some action and do some analysis and some repairs on those facilities. And again, Ignition, we've built this application on Ignition, so we get Ignition alarm history. So this is where you would go to view that alarm history. And then finally, we partnered with Inductive Automation to build this alarm rationalization tool. And so this tool allows the users of iPOC to configure their alarms natively in the application, and you don't have to go into an Ignition designer and open up tags and configure alarms in the edit tag wizard inside the designer. You can come into this window, find the alarm that is configured in the system already through the tag system, click the gear, and configure the alarm in runtime. So this is very helpful to not only configure the alarm, but also this tool helps you walk through the process of rationalizing what priority that alarm should be. And this is based on alarm ISA standards. So it gives you that power right from the application. So that's a little bit on alarms. I'm going to jump over to status. This is where people like to focus when they take a look at iPOC. One of the big things when we've talked to people using products that do well lift analysis and control are group status. They want to monitor wells and look at wells from a group level. So I navigated here to status group. And from here, you choose a group. And these groups are defined in the administration side of the application. I'll show that here in a second. But we've defined a couple of groups here, like Pat's wells, for example. I'm going to go ahead and click that. And in that group, I have a couple of wells that I've added to my group that I care about. And at a glance, I can see the live status of all of those wells. I can see whether they're communicating or they have a comm fail, what the well name is, how many alarms are active, whether the well is running or shut down. If it's running, what state it's in, what its runtime percentage is for today, how many times it's cycled on and off today, what the idle time setting is in the controller, what the stroke length is set to that unit size, strokes per minute, and then pump fillage. So a lot of this is very kind of common information that users want to see. But what if I want to see other columns? Again, this is a demo environment, so a lot of this is dummy data. But up here at the top, we have this gear icon. This allows users to customize the columns they want to see. And we're adding more columns depending on your situation and your environment to let you choose the columns and the information that you want to see. So highly customizable, and that is the group status page. You can always branch open this well navigation tab on the left to go change groups. Branch that back. And then there also is the functionality of starting wells and stopping wells from the group status page. And this allows users to start groups of wells at a time, not one at a time, but groups of wells. And so if I were to click group startup, this lets me know, hey, of your group, Pat's wells, these 6 wells are currently shut down. You can see in the back here the 6 wells that are showing shut down. Group startup only allows you to choose wells that are shut down so that we don't send a startup command to a well that's already running. From here, though, I can check some of these wells and start those, or I can select all of these wells and start all of the wells. So this is very handy for coming up after a shutdown or an outage and needing to start up certain wells so you don't have to navigate to each well one at a time and issue startup commands. We also have the same thing for group shutdown. And where I've seen this be very valuable is when there's a problem at the facility that these wells go to, and we need to shut down all of the wells in that area so we don't overwhelm a line or a facility. We can shut down all of those wells with a couple of clicks. So for example, hey, all of my wells in my group are at my lease or at this area, however you have those groups defined, select all of those wells and shut them down. Before I close that window, what this also does, the group startup and the group shutdown, when you select these wells and issue a shutdown, this actually in the shutdown status column over here will show you the status as it steps through each well. So it'll actually give you live feedback on what it's doing for that group and those wells in that group. So it'll say for the first well, initiating shutdown, and then shutdown confirmed, well is shut down. And then you'll notice the run state will change live on this screen as it iterates through those wells. And it'll work its way down through the list and shut down each well one at a time. And then if there's any issues, it'll also provide you with the reason why it couldn't shut the well down or a failure, error or code to let you know what the problem is. All right, I'm going to jump over to the well status page, and I'm going to choose one of the wells that I've put in my group. A lot of these wells are again, just dummy wells that we have in the system for the demo. And they show like they're running or not running, but we don't have live pump off controllers here in the office. We do have this one lab pump off controller from Lufkin in the office here for the demo environment. So I am going to show this one. But before I do, I'm going to highlight some of these icons over here. So as you're navigating through the tree, we have this idea of static groups. Those groups are groups that have been defined, and wells have been put in those groups and they stay static. Those are the wells I care about. Those are the wells in my area. Those are wells in this lease, this location. Those can be defined and they stay static. We also have the idea of dynamic groups, and these groups are defined by rules or conditions. So when these groups get created, you define what criteria you want to be monitored, and wells will be inserted or removed from this dynamic group automatically based on those conditions. So for example, I have a group called 24-hour runtime. Only wells that meet that condition will show up in this group. We currently have no 24-hour runtime wells. So when I branch this open, the branch disappeared. I don't have any 24-hour runtime wells. But if I look at running and I branch that open, that will show me all of my running wells. If I branch open shutdown, that will show me my shutdown wells. And again, demo environment. So there's always the fun live demo behaviors, but that would show all of your running and shutdown wells. So it's very cool to see wells automatically show up in those dynamic groups so that you can find the things you want to find very quickly. So I'm going to come back to static groups. We go to my wells, Pat's wells. and I'm going to double click Lab Lufkin RPC. Before I double click it, there is a right click functionality right here. I'm not sure why it's not showing in the demo, but if I right click this well, this gives me a lot of context information about the well in a pop-up. And I can also issue lots of commands directly from that right click. I can start the well, stop the well, idle the well, clear alarms on the well, and I can also navigate to different parts of the application for that well just by that right click. So I am going to double click the well to go take a look at the well status page. So this is the well status page. It has a lot of the information you would expect to see on other well analytic platforms, well lift analysis platforms. So up we have at the top left here, we have the well name. We have some very generic information about the well. We have what its run state is, whether it's running or shut down based on this icon, and then what is its run state. So this well is shut down, and it's currently down due to a malfunction minimum load state. I can see what type of controller it is. It's a Lufkin Well Manager rod pump controller. I can see the live clock in the unit. I can see what IP and networking configuration is set up for that unit. So this is the IP address, Modbus TCP port, and the unit ID. In this middle section here, we have real-time values. These can be customized. So don't think these are the only things I can show on this container, but these are the things that we have shown by default for a Lufkin controller. And these are simulated values. I know it's shut down and we're seeing numbers, but it's just so that we can simulate moving data. But strokes per minute, current horsepower, position, RPM, torque, load, pump fillage, and then any other value that's available in the controller can be displayed here, as well as analog inputs. So if you have a transmitter on the tubing line or the casing line, or you have a tank nearby with a level transmitter that's wired into the controller, all of the analog inputs can be shown here as well, so you can monitor those. And then lastly, we have daily values. These are the things that you want to monitor that are accumulating over today and yesterday. So we have cycle, percent run, total strokes, there's lots of different variables in the controller, depending on the controller type, that you can pull out of that controller that we have in our UDT and our tag. All of those can be displayed here, but this is what we show by default for a Lufkin. Taking advantage of perspective and CSS, there's a lot of cool things that we've done on the screen, like, hey, I want to see this bigger or smaller. You can click and drag things like you would expect from a normal web application. So a little fun nod to perspective and CSS. On the main part of the window here, we have a card viewer built into the screen, and we also have a trend tool built into the screen. If I want to see the card viewer larger or the trend container larger, we have a minimize, maximize button here. And this allows us to get that trend section out of the way and focus on just the cards, or vice versa. Or I can leave both up. All of the things that are built into Ignition's Tag Historian are available in this trend component. We have automatically populated the things that we have heard from users being the most popular things, the most common things they want to trend. Those are on here by default, but other things can be added by the user. You can very quickly go in and say, I want to look at, a week of data, a month of data, or this time range. All of that can be done straight from the well status screen. You don't have to navigate to a different trend screen. All right, let's take a look at the card viewer, because this is the big component of pump off controllers and analysis tools out there on the market, is viewing cards. So what we are doing is grabbing the cards from each controller type that we support and storing them into our backend database. Some models out there on the market do not generate a downhole card. They only generate a surface card. A lot of the newer units from Lufkin, Weatherford, and some of the other manufacturers, they generate a surface card and a surface card and a downhole card. They also generate startup cards, shutdown cards, and alarm or failure cards or malfunction cards. Depending on what the controller supports, we grab all of those. So here, for example, on a Lufkin, we have a surface card. This is the blue card here. We also have a downhole card that's shown in red. We can also at the top just show the surface card, just show the downhole card, or show both. And depending on how many cards are in the system, you can flip through them here on this container with these left-right arrows. We also allow the users to grab cards ad hoc. So if I'm in the application and I want to grab a card right now, I can choose what type of card I want to get, hit get card. It would go connect to the controller, pull that card data, bring it in, store it in the database, display it on the screen. Or we also schedule card collection, and that can be scheduled at any frequency that you desire or request. Right now, we default it to once an hour. We grab cards for all controllers, but that can be changed very easily. So here we have some cards that we've collected in the past when we had a unit in the field connected to an actual live controller. So that's what this is from. It's actually a live controller in the field. And I can flip through these cards with the left arrow. So that shows you how to view history here straight on the well status screen. But what if I want to look at a lot of different cards and overlay them on top of each other? Right here at the top where it says card viewer, we have this kind of pop out button. I'm going to go ahead and click that. This is where it shows all of the cards in the system for this well. Same kind of functionality that you would get on the container over here, where I can grab a card from this screen. But what I'm going to do is click this button right next to the card, and I'm going to click that to display the card on the screen. And by clicking these, it starts to overlay them on top of each other. And this helps show changes that have happened over time. The other thing that we're doing on this screen, in addition to displaying the surface and downhole card, is we're showing the header information about that card. So for that card, when was it grabbed? What's the timestamp on that card? What's the surface min and max load on that card? So I don't have to look at the chart and try to figure out what was the maximum load or what was the minimum load. It's already pulled in from the card header data. What's the stroke length on that card? What's the strokes per minute on that card? Just some general information. Each controller type supports different header information. This is what comes back from a Lufkin. And finally, a lot of the questions we get around cards and pulling cards and showing the data for cards is, what diagnostic tools do we have for cards? And we strategically decided not to do any type of diagnostics natively in iPOC. We didn't try to write our own logic to determine what's happening with these cards, whether or not there's a gas interference or parted rods, or what the pump fillage percent is, and if you could speed up the unit or not. What we have done in iPOC is leveraged its ability to connect to large language models or AI tools. And what we're doing is sending all of this card data to AI models and then having AI give us those recommendations. So I'm gonna go ahead and click this Get AI Analysis button here at the bottom. And this is actually sending all the load and position data on the card that I have selected in the card viewer to one of the large language models that we support natively. And then that large language model is returning back analysis on that card. So it usually only takes about 5 or 10 seconds, but here you can see the return we got back from, I think this one is generated by OpenAI. But what this does is it summarizes that load and position data and gives you back a really nice kind of HTML markdown view of that information. It also has recommendations on how to potentially optimize performance and production. So depending on the card, it obviously comes back with different results every time and gives you optimization recommendations, which is very cool. And it's another just very interesting and I think unique way that iPOC is integrating with kind of the technology of the future. Everyone is talking about, how do we leverage AI? How do we incorporate AI into our systems? I think with this type of system with pump off controllers and the data that's generated from pump off controllers, specifically cards, it lends itself very well to AI functionality. So that's what the AI analysis looks like for cards. We have a lot of other ideas on how to utilize AI for different parts of the application, but that is one main piece that we currently support. Okay. I'll move up to the top right of the screen here. We have some control functionality. If the well is being scanned by some type of a scanning agent, either through KEP server, top server, AutoSol, ACM, and those OPC servers are responsible for scheduling the scans to pull the data, then users can come in here and demand a scan whenever they feel like it, so they don't have to wait for that next scan. Some legacy radio systems out there in some of the older fields are running off 900 megahertz serial or have some type of round robin polling. And so it may take a little bit for those scanning agents to pull all of the wells in that well group over the master radio. And if a user doesn't want to wait for that polling to get back to this well to get new fresh data, they can hit demand and it throws that well at the top of the queue and you get live data back immediately. So that's a very useful button for some of those legacy radio systems. Then we have the ability to control the well from here. And I know I showed some of this on the group startup, group shutdown screen. And it's essentially the same functionality, but this allows you to do it per well, one at a time. So if I'm on my well, Lab Lufkin RPC, and I want to stop this well or start this well, I can easily do that from this screen right here. And by hitting control, I get this pop-up modal, and I can start, stop. Lufkin support resetting alarms. And then we also have a sync clock functionality for all of our controller types. So that can be clicked right there, and we can sync the clock if the clock isn't accurate. Okay, moving on to the next button here, we have configuration. We do support a lot of configurations remotely from iPOC. So depending on the controller type, we have different things that can be done. But for a Lufkin, these are all of the the controller configuration points that we support. Weatherford, Apergy Smarten, some of the other controller types that we support, this screen would look different based on each controller type. So I can look at all the analog inputs that can be configured in the controller. I can look at belt slippage control set points. I can look at downhole configuration set points, and all of these can be changed right from here. If I have the privileges or the access to change them, just by changing them right here, go ahead and do one change, that just wrote to the controller and changed that set point. It's that simple. I don't have to stage it and hit write and hit commit. It's live. It's just like you would expect from a SCADA system. So just by changing a number, that issued that set point change to the controller. So all of these are available from this controller dropdown. We also support, I'm going to skip these two and I'll come back to them, but set points. These are specific buckets of tags that users have defined, that they're kind of items that they want to change frequently or want to monitor more than everything that the controller has in it. So if I look at set points, I can look at analog input configuration, equipment, so there's different rod and taper settings here, and all of the set points in the controller. So for a Lufkin, this is what is built in by default. These can be modified and changed as needed, but each controller type has different sets of set points that we have heard feedback from users on what they typically change. So that's where you would go to kind of monitor and change those user-defined set points. Under database, we have the ability to store pumping unit, surface equipment information, motor, surface equipment information about the well. And because we aren't generating our own diagnostics in the application, because we're using AI, this information isn't used for anything per se. It's not generating, analysis or optimization recommendations or providing some type of a, hey, you might have a problem because we're using this data to generate some type of optimization recommendation. It's stored in the system just for inventory tracking, and that's a big thing for a lot of the users we've talked to, is they don't have a platform where they store what types of pumping units are on their wells. They don't have an external reporting solution that has this type of information stored in a database, and so they need to store that inside of the application. So we have continued to support it just for that inventory tracking mechanism. So for pumping units, users have a lot of pre-built options in the system. So I can choose what type of pumping unit it is, if it's conventional or hydraulic or air balanced. Depending on what you choose as you work your way down these screens, it filters the next dropdown. So when I choose conventional, I get a list of every manufacturer that makes conventional pumping units. And then depending on what manufacturer I choose, I get all of the sizes that manufacturer supports. So a user can say, hey, I have a conventional, American conventional, and it's a C320, 256, 120 size pumping unit out there at the skid. And what is the crank configuration? Again, depending on what I choose up here, these automatically update with options, but I have the ability to rotate the counter balance cranks clockwise or counterclockwise. This unit is rotating counterclockwise. This size unit has 3 crank holes. If you put the crank hole in slot 3, then you can only go up to a 90-inch stroke length. Slot 2 can go up to 104. Slot 1 can go up to 120. Say, hey, I'm in hole 2, and I've measured my stroke length out there in the field, and I'm running at 87.9 or 88 inches out in the field. Any information about the counterbalance, and then motor information. What type of motor? If it's a NEMA D, what size? Say it's 20 horsepower, and that's the size and setting. And if it has a power meter, what type of power meter, if it's one-way or two-way. So again, not used for any analytics, but allows you to store what's out there at the skid in case I need to do maintenance, or if I want to replace it, or if I want to do repairs, I know what's out there. Same thing for downhole. Downhole equipment, we have the ability to categorize and store all of the rod information, casing information, how many casing strings are in the hole, at what size and what length, and then tubing. And then we have information about the pump. So how deep is the pump? What size pump or plunger is it? What type? All of that information. So that's under the database section. And then for analog inputs and discrete inputs, this is where I mentioned before, if you have like a tubing pressure transmitter on the flow line, and you have a casing pressure transmitter on the casing line, and you have a tank nearby that's wired in with a level transmitter, this is where all of those can be configured. So if I have a casing pressure transmitter, I can choose, okay, I'm going to configure a casing pressure, and I'm going to enable this input. And then Lufkin has its analog inputs defined at these registers inside of their controller. And we pre-built these so that all I have to do is choose, okay, I have the casing pressure wired into analog input 3. And I can either choose to bring in that value raw, 4 to 20 milliamp, or have the controller scale it if that channel happens to have been scaled in the controller. If I choose scaled, then I don't have to do anything in terms of scaling. If I choose raw, then I can come down here and use Ignition's built-in tag functionality to scale that value. I can say, hey, this is a 4 to 20 signal, and I want to scale it 0 to 500. And now I display the raw value and what I'm scaling it to. So there's a lot of flexibility with analog inputs. I can also configure any alarms on any analog inputs that are configured. So for casing pressure, I can say, hey, I want a high pressure and I want a low pressure alarm. And I want it to be a medium priority for a high and a low priority for a low. And I want it to trigger if it goes above 50 PSI and if it goes below 5 PSI. And that's it. All of these are live as you change them. And now I have a casing pressure configured with these scaling ranges, and I have a high and low alarm configured. And same thing for digital inputs. So different controllers support different number of analog inputs, different number of discrete inputs, but all of those are configured here from this configuration screen. So that is configuration. Moving on, alarm history. This is very similar to the alarm history tab that I showed earlier in the presentation, but this what alarm history and audit log allow you to do is easily get to the alarm information for just this one well that I'm looking at, Lab Lufkin RPC. I don't have to go to the main alarm history window and go find my well. I can just click alarm history and it's already pre-populated with my well, and it'll go find it in the journal, and I can focus on that well and do analysis. Same with audit log. This is opening up the audit log for the entire system. Audit log includes any buttons that have been clicked in the application, any set point changes that have been written to the controller, any configurations to surface and downhole equipment, any analog inputs that have been configured, all of that would be configured and shown here in this audit log, and would show anything any users have done on this well in the system. All right, so that's a lot. That's the well status page. Moving on, we do have a couple other features to show status information. We do have a map feature that is leveraging, again, built-in ignition capabilities. But the map feature, if we configure your wells with the latitude and longitude, then you will be able to see your well on a map and be able to easily visualize where it's located in whatever location you're located at. But what else is also available here is these pins dynamically change based on status. So if a well is running, it's obvious. If a well is shut down, it's obvious. If a well has a communication failure, it's obvious. So it's useful for a lot of different things, but one of the things we would think it would be very useful for is determining whether you maybe have a power failure or a radio issue at a certain location. If a lot of wells in a specific area have comm failures, it might be harder to see that if you're looking at the display like this. It's like, oh, hey, I've got a couple wells with comm failures. But if you look at that same group in a map display and see, oh, they're all grouped together, maybe that site has lost power or has a radio issue in that area. So that's one of the things that we're thinking could be very valuable using the map display, and not something that's used heavily right now, but we think it's untapped, and we're kind of waiting to see what users want to do with it. But we think maps could be a very useful tool in the application. And then finally, we have failure analysis. I think there's a lot of usefulness with this part of the application. You may store failures and different information about your wells in other systems, ERP systems, and that data is stored in a place where you can report on it with tools like Power BI or some other reporting tools. But if you don't have those tools, we've built this into the application to help you do some of that reporting and analysis on failures. And so what this screen allows you to do is at a glance see all of the failures that have happened across your wells and add new failures as they occur in the field. So if I had a well fail, I could come into this screen and document that. I could say, hey, this well, Lab Lufkin RPC, had a failure on this day, and we brought in a workover rig and rigged up on the same day, and we rigged down 3 days later, and we returned the well to production on this day. And the reason we did this is because of, and we've pre-populated this with a lot of different options for why the well was pulled and what component failed, and what, depending on what component you select, it also gives you what subcomponent failed. And then what failed? Was it electrical issues, mechanical issues? Did something plug? Or you can choose other and provide notes or unknown, and what mechanism. And then you can also document what causes were found when the workover rig was on the well, and you can enter numerous things here. We found that, and we found that, and we found whatever. And these are the services that we did to fix the well. Maybe we acidized the well, and maybe some notes about the acidation job. And we also, on this day, replaced the pump, and any notes. And then any general notes. And then what's the total cost to fix this well? All of these services and all the things that we found, and hiring the rig, and all said and done, what did this cost? Maybe $100,000 to fix this well when this well failed. And then when you save it, that goes into the database. And then over here at the top, I can look at that record that I just entered, which is here, or I can go look at failure analysis, which shows all of my failures using some report mechanisms and queries. And I can see all of my failures, how much they cost. And if I click any of these wells, then it also shows me what was the #1 cause for all of the failures that have happened on this well. So I can very quickly see, okay, this is the one that cost me the most amount of money, and the thing that happened the most number of times is buckling or whatever is the most common thing that you have happen on your wells, you would hopefully see that here and it'd be obvious. And you say, hey, we've got a problem with this type of failure that's happening across all of our wells. We should figure out something to do about that. And so that's failures, just some things that we've added over time as we've heard feedback from users on what they need. And that is failures. Moving on, we do have trends built into the application. So again, leveraging out of the box ignition. This is allowing users to come in and choose a well and trend the data that they want to see for their well. This is a special ad hoc trend tool that we partnered with Inductive and built that allows users to trend data, but not have to open it from scratch every time. Users can also save and load customized trends with these buttons up here. So this is available on the Ignition Exchange, but this is a specialized trend window that lets you save and load information. This trend window, which is called well trends, is pre-configured trends based on controller types. So when I chose Lab Lufkin RPC, this automatically threw 7 trends on my chart because it knew, hey, I'm a Lufkin, and this is what you typically trend when you look at a Lufkin. And that's configurable for a user can change those tags that they want to view per controller or controller type. Ad hoc trends is just a blank trend tool that lets users go pick any tag in the system and trend it. So that's the difference between well trends and ad hoc trends. Base tool, and then specifically for iPOC, choosing a well and us grabbing the data that is configured in the system for that well or controller type. And then finally, I'm going to jump over to admin. So the administration section of the application lets you look at the audit log. I shared this a little bit ago in the well status page. Audit log lets you see all audit history across the application. Again, button clicks, reads and writes to the controller, set point changes, database changes, anything that was done in the application is logged in the audit log. This one under the administration section would show everything in the entire system that happened across the entire application and every well and every user, not specifically one well at a time, but everything. You can filter by start and end date and search for keywords to find certain things, but this is meant to be, I want to audit and look for everything in the system. Then we have a diagnostic tool. This helps any administrators in the system look at CPU and memory of their server, any configurations with OPC servers, any device connections that are native in Ignition, and any database connections the users have in the system, and monitor the health of those. The 2 pieces from the admin page, though, are how do I configure a well? And Al touched on that during the PowerPoint presentation. How do I configure a well, and how do I configure a group? So if I go to well management, this is how we currently have wells being added to the system. And right here, I can see all of the wells that are created in our demo environment and whether they're enabled or disabled, what their well name is, what type of controller they are, and if they're connected to a different type of OPC server. By clicking a well, I can edit the configuration of the well. A docked container shows up on the right. I can make any changes to the configuration and hit save. Like Al mentioned before, any of those changes are automatically updated in tags, device configuration, and database configuration. Adding a new well, it's similar to clicking a row here and hitting edit, but if I hit add, that's going to give me an add new well dock on the right. I can enter a well name, choose a controller type. Our list of supported controller types is growing, but we currently support a lot of the main manufacturers like Lufkin and Weatherford and Smarten. Choose what type of OPC server we're going to be connecting to, whether it's AutoSol ACM, Ignition, Cap server, or Top server. And then the IP address configuration. What is the device name in that OPC server? What's the configured namespace? What is the OPC server name And so this basically builds your OPC item path for your tags and your UDTs. And then if you have a unit ID for Modbus TCP, filling in that information and hitting add, like Al mentioned before, that's going to create automatically all of your tags in Ignition, device connections in Ignition or third-party OPC servers automatically creates those channels, devices, schedules, anything that's needed for that OPC server type. It will create all of those using API calls, and then it'll also create all of the objects needed in the database for that well, just by entering those few pieces and hitting add. So we wanted to make it very easy to add wells. That was a huge concern and constraint for a lot of users and some other applications they're using, is adding wells is very complicated, and you almost need to get an engineer involved to add a well or remove a well from a system. All right, Al, I think I've made it through the entire demo. I'm going to flip back to the homepage here, but I'll bring you back on.
Thank you, Pat. That was great.